Hi, so in this chapter we're going to finalize our move over to Arduino from using Toit and Jag. But before we launch into code, we're going to start by diagramming up the code that we're going to write. It's good to get into this habit, particularly when we're looking at C code instead of something like Jag, Toit. Toit's a lot more modern language with more functionality. For example, it manages fibers for us, so we can more easily have concurrent threads of execution. In Arduino, we're going to manage that all ourselves. So we're going to set ourselves up for more success by starting with some nice sequence diagrams. This picture will get more complicated as the semester goes on, but to start out with, we really just have two actors that we're going to worry about. Our microcontroller, and on the other side of the communication channel, is your laptops. This is called a sequence diagram, and essentially we're just going to say throughout the lifetime of these two entities, how do they interact with one another? Your laptop might have been on for days, but we're really just going to focus on what happens when you start the microcontroller. Well, what we'd like to start with is to have the microcontroller connect to Wi-Fi. The next thing your microcontroller will do is once it's connected to Wi-Fi, it's going to start a WebSocket server. Eventually, we'll put the server's URL and port on the display, but for today, just to keep things simple, we'll have you read those over the serial monitor, much like we were doing with Jag Monitor. Another important thing to note here at the very beginning is we'll say that our microcontroller is in a disabled state initially. After the sequence diagrams, we'll see how this event, disabled, is used by a couple of different modules. Your microcontroller really shouldn't do anything until some form of communication is initiated by the laptop. So once you, well, I should also say this is ignoring the serial interface. So this is really just a sequence diagram for the WebSocket communication. Because they do have a second channel of communication, which is what I was about to mention. Once you've read the IP address and port from the serial monitor, your laptop will connect to the microcontroller. At this stage, your microcontroller doesn't really need to do anything, but maybe it'll print to serial that there's a connection. The more interesting form of communication going back and forth are going to be the heartbeats. The laptop will send a heartbeat. And the moment that the heartbeat is sent, your microcontroller is going to put itself into an enabled state. And it's going to set a timeout for itself. So after a certain amount of time has passed, after this window has passed, if we haven't received another heartbeat, we'll immediately go back into a disabled state. So that's one scenario. Another is we get a heartbeat, and then immediately, or not immediately, but within the timeout period, we receive a second heartbeat. And let's say we continue to receive those heartbeats until finally the laptop properly disconnects. Well, when we receive this first heartbeat, we'll go back into an enabled state. And each time, we will reset our timeout window. And so we'll never have our timeout trigger, and we'll stay in the enabled state until we see the disconnect at the end. In which case, we'll go back into a state of being disabled. So what does this mean to be in enabled or disabled state? Let's look at another couple of useful diagrams. We'll have our WebSocket diagram, which starts out in a disabled state. And then can occasionally jump into an enabled state and stay there. We'll start here. And whenever we receive a heartbeat, we'll jump into an enabled state. And on a timeout, we'll jump back to the disabled state. So that's pretty much what I have drawn above. The more interesting part is when we have something that we're controlling on our microcontroller that's relying on being in an enabled or disabled state. Let's have a simple example here of an LED. And let's say that our LED has two states as well. So our LED can go from an off state, where it starts on initialization, and let's say when it receives the enabled event, it goes into an on state. And likewise, when after a certain amount of time, if we have the timeout triggering us back to a disabled state, when we recognize that we're in a disabled state, we'll jump back to the LED being off. This can get as complicated as we'd like. So, for example, maybe instead of just being in a state of being on, we go into two states, one where it's on and one where it's off, and we jump back and forth and blink. But we only do that when we're sort of enabled. So we can make these more complicated, and you can probably imagine another one of these for our motors later on, which have an on state and an off state, and jumping back and forth depending on where we end up in our WebSocket. I don't want to put too much complexity into this first version though, so we're going to start with just having our WebSocket and controlling an LED. In the next video, we'll actually jump into our code for doing so.